In this video, we'll look at how to use the area model for multiplying, and we'll start with some examples here, maybe that are a little bit simple, but we'll go ahead and have a look here. So I'm going to start with let's say 5 times 18. So we can write 5 times 18. There are lots of ways that we can do that, but I'm going to start with an area model, and the area model is based on finding the area of rectangles. Please forgive my bad looking rectangle, but hopefully you get the idea. So we're going to say that this side length has this side has a length of 5 and the other side has a length of 18. We're going to split that 18 into both 10 and 8. So we'll split it into the tens and the ones. And if we had a number in the hundreds, we could split it into the hundreds, the tens and ones. The procedure here would be the same. And now we're going to find the area of this little box here. So it has dimensions 5 by 10, so we get 50 there. And the other side has a dimension of 5 by 8, which is 40. We add those together and we get that 5 times 18 is equal to 90. I should have left a little more space there. All right, moving on, we'll just sort of take it up a notch just a little bit. So let's do 15 times, try that again, 15 times, we'll go 18 again, just to show how things are a little bit different here. Now we're going to have a slightly bigger box because we actually have a tens column in each of our numbers. And we'll split the two numbers into their tens and their ones. So I'll keep 18 along the top here and write it as 10 and 8 and then 10 and 5 here. So same idea, we're just going to find the area of these individual boxes. 10 times 10 is 100, 8 times 10 is 80, and then down here we'll have 5 times 10 is 50. And then finally 5 times 8 is 40. So we can go ahead and add those. So 15 times 18 then would equal 100 plus 80 plus 50 plus 40. And we add those all together. What does that give us? That gives us 270. So that's how we can find the area, product using an area. And I use that example because it's a really concrete way to see what's going to happen here once we get into the idea of using the algebra tiles. So next up, I'm going to look at what about 1 times 1? Well, if we were trying to represent that as an area, we would say that we're talking about a rectangle that's 1 by 1, or in this case a square, and it would have an area of 1. We can do the same thing here with an x times x. So it would have a length of x in one direction and a length of x in another direction. So x here and x here, giving us an area of x squared. Now, both of these are squares. This doesn't just work for squares, obviously. So for example, if we wanted to look at 1 times x, actually maybe I'll do that down here. 1 times x. I'll just use a dot for multiplication so as not to get confused with the x's. Same idea, it would have a length of 1 and a width of x. 1 times x would give us x. Now you might say, well, why did we waste our time kind of doing all of that? The goal here was to kind of get used to the algebra tiles. And if you look here, I'm just on the Polypad website. Obviously this works with physical algebra tiles as well, but I'm going to use the ones on the Polypad website. It really solidifies why each of the tiles is used the way that it is and what each one represents. I know physically when students use algebra tiles, sometimes they have a hard time remembering what the lengths of the tiles are, but with a little bit of practice, they get the hang of it. The nice thing here in Polypad is that they're all labeled as to their areas, and then you can kind of work backwards and figure out what each of the dimensions on that is. All right, let's get into a more sort of algebraic type example. Let's look at what does 3 times x plus 2 look like. So 3 times x plus 2. All right, so in order to do this, I need an x, and I need plus 2. There's my x, and there's my plus 2. Whoops. There's 1, and here's 2. And then I need 3 of these. So sometimes what I'll do is I'll actually write down here what am I doing here. So this is an x plus 2. kind of going in this direction, and going this way I need a 3. So that helps me sort of keep track of what I need. Well, I have a 1. Remember that this dimension here is 1, so I need a couple more, and I can either drag that out and see, okay, there's a second one, there's a third one, or just copy and paste. And for this example, students might say, well, this seems kind of like a waste of time. Why am I doing this? But again, it gets them used to the idea of making a rectangle, because that's exactly what we're doing. We're making a rectangle that has dimensions of 3 and x plus 2. And so now you can see that, and students can see, that 3 times x plus 2 is just the sum of all of those areas. Again, we're kind of building up the ideas so that when we get to harder questions and harder examples, students know what to do. So they just count up the x's. Well, there are 3 x's here, and there are 6 ones, so we get 3x plus 6. So that's how we can do a constant multiplied by a binomial. Let's go a little bit further here, and let's look at maybe maybe I'll just start a brand new page here. Let's look at the example x plus 1 times x plus 2. So fairly straightforward example. But again, if students can kind of build this, then they can see what's going on. So again, I need one dimension to be x plus 2 and one dimension to be x plus 1. Really good to emphasize with students that it doesn't matter which dimension goes where. Well, if this first multiplication here is x by x, we need a rectangle that is x by x, and we've already talked about how that's the x squared option. So there's our x by x. That gives us an x squared. The next section, and again, this where you go here depends on what you want to do or how you want to do this. I'm going to go from the bottom here and say, hey, I need a rectangle that is 1 unit this way and x units this way. Well, that's just this one right here, 1 by x to give us 1x. And over here, we have a 2 written. It might be helpful for some students to see that 2 as being written as a 1 and another 1. At first, that might be helpful for students. Ultimately, students should be able to kind of work back and forth. So we know that this dimension has to be 1, this dimension needs to be x. So that's our 1 by x rectangle, which looks like this. So I've got 1 there and 1 there. It doesn't take long for students to realize that x plus 2 is going to be an x followed by 2 1s, and so they can do that. The last thing that we need to do is fill in the bottom of our rectangle down here. That's this part right here. And we do that by looking at, well, what size blocks go in there, but also looking at what are the dimensions here that give us that multiplication. So this dimension here is 1, this dimension is 2, so 1 times 2 should give us 2, and we know that it's positive because a positive 1 times a positive 2 is equal to 2. All right, so we've done that, we've built our rectangle, and then we can now say that the product of x plus 1 times x plus 2 is the sum of all of the areas that we've just created. So we have 1x squared, we have 1x at the bottom, plus 2 more x's along the right-hand side, plus 2 here. And again, students can see that these numbers are the same numbers that you would get if you were expanding using the distributive property. So we get x squared here plus 3x plus 2. So that is the product there. Let's look at what happens if we have a negative number, and then we can maybe do one that's a little more complicated. So in fact, I'm just going to use the same example. I'm just going to change that plus 1 to a minus 1. So we'll do x minus 1 times x plus 2. So we'll have x plus 2 along the one side. We'll do an x minus 1 along the other side. And I'm just going to draw lines in here just to help us build. So our first little box here will be x by x. That's going to be an x squared. And I might need to adjust my numbers a little bit here. Just slide this one down a little bit further. And let's start on the top right. So we know that this is 2 by x. So 2 by x will be 2 in the one direction, x in the other direction, and we can see that we're going to get 2 x's here. Just slide those together. Now here's where things get a little tricky and students need to be doing some thinking. So the goal is to make a rectangle, yes, but they also have to think about what is the area of that rectangle. So this dimension here is -1 and this dimension is x. So if we're finding the area there, -1 times x will be a -x. So I actually need a -x tile rather than just an x tile. So there's our -1. And again, they have to pay close attention to what's happening over here. The dimensions here are -1 in this direction and +2 in this direction. So -1 times a +2 will be a -2. And so we can drag out our two negatives. And again, students can see what's happening here, and then they can answer the question. They may be able to just look at this and come up with an answer, or they might just start by writing this down. We've got an x squared, we have the two positive green x's, we have a negative x that's burgundy, and then we have -2. The nice thing about this is that students can use that idea of zero pairs and say, oh, well, I have a positive x and a negative x. I'm just going to drag that in here and simplify. So they can simplify that as they go, which gives us an x squared plus x minus 2. And again, hopefully that helps. You know, if students are struggling a little bit with the algebra here, hopefully that helps a little bit for them to see. All right, let's do well, we'll stop there for now, I think. So the algebra tiles are a great way to introduce. Lots of students don't like them because there's lots of sort of fiddling around and they have to do some thinking. But once they get used to it, then they can actually look at an area model instead and simplify this. It's a nice natural next step. So with the area model, what we'll do is we'll still make a rectangle. It'll still have dimensions of x plus 2 and x minus 1. And what we'll do is we'll actually create a rectangle. Sorry, this is not a very good rectangle, but hopefully you get the idea. Just like we did at the beginning with the numeric values that we did, x times x, we're going to find the area of this little part of our rectangle. So x times x is x squared. This dimension here is x, and this one's plus 2. X times positive 2 is 2x. This one here is -1, and this one's a positive x. -1 times x is -x. And then finally, -2 times +1 is going to be, sorry, let's try that again. -1 times +2 will be -2. And again, so students can kind of move past the physical hands-on tiles. I think it's important for them to kind of experience that because they get a sense of what they're doing, and then they can kind of go and see what their answer is. So this would tell us that x minus 1 times x plus 2 is equal to x squared plus 2x minus x minus 2, and then they can collect like terms. And again, we can do the same thing over here, which was having a rectangle. And I always tell students I never draw a rectangle to scale. We just use it to represent the different quadrants or corners, just to help us out here. So this was an x plus 2 and an x plus 1. So same idea, x squared here, 2x, 1x, and then 2. And then they can, write their answer and simplify it. The same goes for the first example. I did erase the first example, but the first example that we did was 3 times x plus 2. So we can, again, use an area model rather than building it with the algebra tiles. We can actually say, well, we've got 3 in this direction and x plus 2 in this direction. Well, this area here will be 3x, and the area here will be 3 in this direction, 2 in this direction, for a total of 6. So we can see that it's a nice jump from the algebra tiles to the area model. And what this allows us to do is we're kind of building the foundation to go backwards and do the factoring, which we'll save for another video.